Good afternoon, everyone. My name is Guido Alvarenga. I'm pleased to present my dissertation for you guys, which was supervised by Professor Miguel Alvarenga, and the title is Towards a Tendering Process with an Automated Quantity Takeoff uh, for an Increased Comparability, a prototype. Wait, yes. It passed it to the next slide, right? Yeah. So, yeah, first I will start highlighting some challenges in the public tendering and BIM. So there is a key issue for the need for an accurate quantity takeoff, which is vital for cost control and transparency in managing public budgets. And also, uh, in this scenario, there is a reliance on costly softwares, which complicates the spread of BIM, resulting in many professionals making use of suboptimal tools, leading to inefficiencies. And additionally, cultural resistance and bureaucratic complexities hinders the BIM adoption in this sector. So in that sense, my work aims to address these challenges by developing an automated quantity takeoff using Python and libraries such as IFC OpenShell and focusing on reinforced concrete elements. For this, a structural methodology was implemented, addressing the formwork issues and defining the modeling guidelines for an accurate result. Also, some information requirements were also established for a successful model parsing with the framework, and these information requirements were integrated into an EIR for public tendering. And finally, the tool was verified against a manual verification for accuracy check. So, in this study aims to align with and contribute to some practical benefits in the public tendering sector, such as the increasing adoption of BIM, which is backed by the government policies and industry efforts. Also, the shift towards automated quantity takeoffs reduces the reliance on manual methods, enhancing both efficiency and accuracy. And also, a custom developed script offers solution that can be tailored to specific project needs while maintaining a comprehensive approach, which aligns with the broader advantages of OpenBIM, which through its open standards enhances the interoperability across the whole process. So the first step of the methodology was to address the challenges of modeling formwork in BIM, as most of the softwares lacks built-in tools for this purpose. And also the IFC schema also does not include a specific entity for this element type, which necessitating some alternative solutions. So to solve this, a 2D element type was created using a face-based family template in Revit, uh, which allows the formwork to be modeled directly on the concrete surfaces. But normally the 2D families are typically for annotations. So it was needed to make an extrusion, and then it was possible to assign it as a building element. Uh, but however, uh, for a 2D, for it was needed a 2D element type to ensure an accurate area extraction without the thickness related inaccuracies. So a void extrusion was made of the same dimensions, resulting in this 2D family. And finally, these custom elements were mapped to be exported as IFC covering, so making their quantity takeoff base quantities accessible in the IFC properties for further processing. So to ensure an accurate quantity takeoff, some specific model guidelines specific model development guidelines were established. So first, all of the elements must be modeled using the correct IFC classification. Normally, only by using the appropriate tools in the altering software, this is already enough. But for some elements, such as the footings, it was required some manual mapping. And also the precision is crucial. Uh, so dimensions and connections must be very well defined to avoid overlapping of elements. So columns should take the precedence at intersections with no beams or slabs
नहीं दे
crossing
रहा
their sorry?
जिस नहीं
Ah, with no beams or slabs crossing their sections. And also beams need to be modeled span by span, terminating at their supporting elements, and slabs should also be modeled panel by panel, ending at a beam connection. And lastly, the formwork should be created using this user-defined previous the user defined element type previous mentioned in Revit, which allows the flexibility in dimensions and connections based on the concrete surfaces. So to enhance the interoperability and the data usability, the model was organized according to the class classification system. So in Revit, type parameters were added to the elements for classification numbers and descriptions. And the Revit IFC export were also configured to ensure these parameters were recognized as the classification ones during the export. And for the quantity takeoff, the work breakdown structure was aligned with the Portuguese rules of measurement, specifically for reinforced concrete structural elements. So the tool development focused on some key IFC schemas components to be parsed by the script. So the concrete elements, like footings, columns, beams, and slabs, the net volume was the property accessed. For the formwork, represented by the IFC covering, it was the net area. And for the reinforcing bars, the nominal diameter and the bar length from the preset reinforcing bar common was used. And also it's important to define the IFC versions to ensure the compatibility among the whole process. So this slide is just an overview of the script flowchart, which I will be addressing in detail. So this section details how the script identifies the element during the code execution. So after opening the IFC file and specifying the elements, the global ID is extracted and is used as an identifier to track the quantity processing. So initially, all the quantities are marked as false and updated to true once they are processed. So the WBS code is derived from C-class classification, and the script transcribed the classification reference into the appropriate WBS code and retrieve its description for the quantity takeoff table. And each element is then directed to its corresponding quantity processing. So for instance, if an element has the WBS code for the concrete elements, so the script will add the net volume and the quantities uh, and update the record accordingly. So the extraction of quantities begins by accessing the relevant properties through its property set in the IFC file, using their attributes such as is defined by and relating property definition. And for example, for the rebar weight, the properties like bar length and nominal diameter are extracted and allowing the volume to be calculated and then multiplied by the density of the structural steel for the final weight. So for the other quantities, the process is similar, but it's simpler since the values are directly extracted from the element quantity takeoff base quantities without any additional calculations. So in the section of the quantity processing, the extracted quantities are stored in a data frame. In this data frame, groups the elements and sum the elements accordingly. Uh, and once processed, the data frame is exported to an Excel file, resulting in the final quantity takeoff table. So this section outlines the information requirements for the model to be analyzed by the proposed framework. And this is the template used in the work, which is based on the ISO 78171. And here is a summary of the elements, the information requirements for the elements. So yeah, the prerequisites are consistent between all of them. So it's not uh yeah, the goal is to perform a structural quantity takeoff and and so on. So so the geometrical information is mentioned that the accurate volumes and dimensions are critical, requiring the elements to have like 3D dimensionality as and the relative location defined. And regarding the alphanumerical information, includes the IFC entity and the properties previous mentioned. And to ensure the model contains all the necessary information for to be parsed by the script, an IDS file was created using the ACAS IDS editor. And the results of this verification will be presented alongside with the overall findings later in this presentation. So another key part of this dissertation involved participating in periodic meetings facilitated by the University of Minho researchers, which gathered stakeholders such as Portuguese municipalities and researchers from other universities from Portugal. And the aim was to develop an EIR for public tendering and establish the best practices uh, for defining the information requirements based on a real project experiences. So the structure of the developed EIR aligns with the ISO and includes these topics presented here. So this section aims to highlight the parts of the EIR that aligns with the developed quantity takeoff framework. So the first thing is the project information requirements should include the development of a work plan and financial schedule based on the cost estimates, ensuring the quantity takeoff processes are integrated into the structural design management. Also, in the information requirements, the PIR should connect to the EIR regarding the work map, incorporating the quantities from the model. The level of information need, the previous mentioned granularity of information should support the framework. The acceptance criteria should include the classification system and the IFC version to maintain the interoperability. And also in the methods for producing information, the previous mentioned develop the modeling guidelines should be mentioned, and also modeling the formwork as an IFC covering uh, should be specified there. So uh, the model under analysis is now introduced. So it was developed according the established guidelines. And here is the IDS verification report, which means that no issues was found. So after running the script, the automatically extracted quantities were compared to the manual calculations with the results displayed alongside the the percentage deviation for each element. So overall, the automated quantity takeoff demonstrated a satisfactory accuracy level with a low percentage of percentage deviation across the structural elements. And also the highest deviation was observed in slabs, which can be attributed to model precision and also some geometric handling, particularly since the slabs were modeled span by span and divided around some stair openings. And also the formwork also exhibited some higher deviations, uh, but it can be likely due to manual adjustments, some extensive processes in Revit, and also some differences in precision between the methods were noted since the manual calculation utilizes fewer decimal places, and in large aggregation it can cause some inconsistencies as well. So in conclusion, this study demonstrates the potential of OpenBIM to improve the quantity takeoff process for public tendering. Also by utilizing open standards such as IFC and IDS, an efficient automation of the quantity takeoff was achieved, adhering also to the Portuguese rules of measurement. Uh, yeah, the Python-based tool uh, effectively automated the extraction and organization of quantities, also making use of the C-class classification system. And the validation against the manual calculations confirmed an acceptable precision and reliability. And also integrating uh, the EIR, the quantity takeoff framework into the EIR also aligns the tool with the public tendering needs, enhancing the cost control and transparency. And some future enhancements could include the tool's capabilities to other structural and non-structural elements, and also refine both the modeling and the calculation process within the script to increase the accuracy of the results. Thank you.